This conference will now be recorded.
Hello. Gopi, I cannot hear you, Gopi.
Able to see, Chandra.
Yeah. Okay, thanks, Revati. I think, Gopi, we cannot hear you. Maybe some issue with your audio. Okay, you can reconnect. So we will just start off wherever we left yesterday. So we have the same setup yesterday, what we have done, right? We have created a custom VPC, and we did create two subnets, public and private. We did create one public subnet, one private subnet, and we did create some route tables. We have created internet gateway and attached to the VPC, and we also created NAT gateway, so we can connect our private instance to the internet. We simply quickly validate our setup before we get into the next one, right? So for that, I need the public IP. Go to that public IP. See, you are able to get inside. Go on ping google.com. Since you have attached your internet gateway and everything, route is all updated, route tables are updated, you're fine. Now let's go and see if we can SSH into the private instance and try to see if we can access our internet from there, right? Okay, we are in, see here, 10.0.30.218. This is a private system. So this is possible because of your NAT gateway, right? So this is where we left yesterday, and we have set this all this up yesterday. Let's continue with the next important topics, right? So already we have seen about security groups. When we talked about EC2, we talked about security groups, and security groups act like a virtual firewall at the instance level. Specifically, group operate at the network interface level. That is why when you delete your machine or terminate your machine, still your security group will be there, because security groups are not attached inside the machine. It is attached outside the machine at the network interface level, right? That's a network NIC card, right? So your IP addresses and your security groups are attached to your interface level only, not at the system level. It's just like our the LAN card that we have, right? Only when you attach your LAN card, you will get your IP and you will be able to log into the network. If you remove it, then nothing will happen, right? So it's that. So all our security groups and everything is attached on the network level only. So in security groups, we can only assign permit rules, right? You can only assign allow rules. There is no deny rule. So there is an implicit deny rule at the end of the security group, which means if you say you allow 80 and 443, it is implied that all other ports are not allowed. That's why it's called implicit deny. All rules are evaluated until a permit is encountered or continues until the implicit deny. So it can control both ingress and egress traffic, that is both inbound and outbound. Security groups are stateful because you don't have to define the outbound rule. So you just need to only say the inbound rule. So if the incoming traffic is coming on 22, it knows that it has to go out as 22. You do not explicitly define. That is why it's called stateful. By default, the custom security group that we create, right, it does not have any inbound allow rules, and we have to create our own group. But the default security group will have both inbound or outbound rule. We have seen all these things. Last, this is just a refresher from the EC2 topic. All outbound traffic is allowed by default in custom and default security group. So that means that's why it is stateful. You cannot delete the security group that is created by default within a VPC. So that default security group cannot be deleted unless you delete the VPC. You can use security group names as the source or destination in another security group. This is what we saw when we talked about load balancer. Only when the traffic comes from the security group of the load balancer, your EC2 should allow the traffic. So we added the security group there. So the security group names can be the source or destination in your other security groups. You can use the security group name as a source in its own inbound rule. So suppose you are having a security group called A, and inside that security group source, you can give A as the one of the source itself. So only when the traffic originates from this machine. Security group members can be within any availability zone or subnet within the VPC. They are all VPC bound. So if you are creating a security group inside one VPC, and if you are creating another VPC and creating a public EC2 machine, you will not see that old security group in here because they are all attached to a VPC. Security group membership can be changed while instances are running. That means whenever you wanted to make any changes to the security group rule, you can go and do when the instances are running and the effects are taken immediately, right? The effect will be immediate. These are all security groups. Now, security groups are stateful, and since we are learning about network, we need to talk about network ACLs are called knuckles. ACL is nothing but access control list. Access control list. So knuckles are nothing but network access control list. So where do we attach this network ACL, right? So we know security groups are attached at the interface level, ENI. That is, for each machine you can attach one security group. But whereas your knuckle functions at the subnet level, so it can be attached to a subnet. The network ACL should be attached to a subnet, and one subnet can have only one network ACL. Okay, only one network ACL can be attached to one subnet. If we don't create any knuckle, a default knuckle will be created when we are creating your VPC, and it will be attached to all the subnets by default. The VPC router hosts the network ACL function. So the VPC router knows it can understand the knuckles entry. With knuckle, the advantage here is you can have both permit and deny rules. Both permit and deny rules. Knuckles contain a numbered list of rules that are evaluated in order. The lowest the number, the highest the priority, higher the priority. So we will see how that is being done. But one thing, please keep in mind, you have to write both allow and deny rules, because knuckles are stateless, whereas your security groups are stateful. Okay, it is like having a watchman sitting outside of your front gate. Okay, and if somebody comes in, he will have an entry saying, okay, so and so name and in time and sign, right? When he goes out, he has to sign out time and he has to sign again, making sure that both the entries for in and out are there, right? So because they are stateless, because we don't know if he goes whether he will come that way, right? He gets inside, he has to be allowed to go outside, right? That's why it is stateless. So knuckles are the same way, they are stateless. You need to have both allow and deny rules. And since this is having an ordered number of list of rules, right? You can write rules by using some numbers, right? Say 100 allow, 101 allow, 80, right? Like that you can give numbers, and lower the number, higher the precedence. Okay, lower the number, higher the precedence. We will see about this. So AWS recommends you to leave some spacing between network ACL numbers. See, when we say number, the number can start from 0, any positive integer, or a star. Okay, star means all. So if you wanted to write a rule starting with 0, you can write 0, 1, 2, 3, 4, 5, and you can go on. But suppose there is some emergency rule that you need to write. Somebody is trying to hack your system or something, and the manager is asking you to block that particular IP or particular port or something. What will happen if you don't have any space between 0 and 1? You cannot write anything between 0 and 1. So it is always recommended to leave some spacing between one rule to another rule. So when we are numbering our rule, we will number in such a way that there is some gap of 10. Let's say 100, start with 100, then next rule will be 110, 120. So you can write 9 rules between 100 and 110, right? So that is the advantage. So the recommendation is to leave some spacing between your network ACL numbers. Network ACLs have separate inbound and outbound rules. Each rule can allow or deny traffic. Both allow and deny rules are there. You can allow and deny them, both inbound and outbound. Network ACLs are stateless, so responses are subject to the rules for the direction of the traffic, right? So it depends, like just when the guy goes out, there should be out entry, only then he will be going out, otherwise he cannot go out. So similarly, knuckles are stateless, so you need to have both inbound or outbound. So wherever the direction the traffic is going to, if it is coming inbound, it has the entry should be there to allow. If it's going outbound, the entry should be there to allow. Knuckles only apply to traffic that is ingress or egress to the subnet, not to the traffic within the subnet. Okay, you need to understand this. So since we are setting this in the subnet level, the traffic can come inside the subnet through knuckle, but after the traffic has entered your subnet, there may be 5 machines running inside that public subnet, right? So again, the traffic will go to particular machine based upon for which machine you allow the security groups. If you don't allow in the security group, the traffic will not move. It is like this, right? Your delivery boy has entered your apartment premise. Okay, fine. Now, if he doesn't know which house he has to go and reach, then what will happen? He will be inside the premise, but he will not know which house to go unless house A allows him to come inside, right? He has authorization to get into one house. Until then, he cannot go to any house. He will simply stand there and traffic and it will just be there. That's all, right? So that is how that's what happens. So we always need to make sure whenever any traffic comes through knuckles, it's always entering or exiting the subnet. It doesn't bother inside the subnet to which machine it's going. That is up to the security group to decide. A VPC automatically comes with the default ACL, which allows all inbound and outbound traffic. So so far we have been using that. So we are going to create custom knuckle and see how this actually works, right? A custom knuckle denies all traffic, both inbound or outbound by default. All subnets must be associated with a network ACL. You can create your own custom ACL. By default, each custom ACL denies all inbound or outbound traffic until you add some rules. So when we create a custom knuckle, everything is denied. Each subnet in your VPC must be associated with a knuckle. If you don't do this manually, it will be associated with the default knuckle. So that is how it is associated with the default knuckle. Default knuckle has both allow and deny. So that is why we are able to connect and do all those things, right? We are able to ping and do. Network ACLs do not filter traffic between instances in the same subnet. So that means the traffic will come inside, but it doesn't know which instance is going. It's not going to do any traffic filtering. If it is allowed, it will just come inside. That's all. Knuckles are the preferred option for blocking specific IPs or ranges. Suppose there is somebody trying to hack your system or getting to your network continuously from one IP, say 1.2.3.4, right? And your manager is coming and asking, hey, Gopi, can you please block this IP because we are seeing that some malicious activity is going on in those IP. So the only way that we can do immediately blocking is from the knuckle. Please don't answer in your interview as security group. The interview will trick you and he will ask you, can you block it in security group? No, we can never block it in security group. Security group has only allow rules. We can only block it in knuckles. Specific IPs and IPs ranges can be blocked only from our knuckle. So now, if you would have remembered when we talked about EC2, when I told security group, I told it is the first line of defense. And I told that that particular line will change or the statement will change when we talk about network ACL. Now the network ACL will be your first line of defense and security group will be the second line of defense, or security group is called defense in depth. Defense in depth, okay, DEPTH. So it's now knuckle is your first line of defense. So if you are blocking in knuckle, nothing can come inside your subnet, and even though if it comes inside your subnet, then your security group is your second line of defense. And if you are allowing it in security group only, the traffic will go to that particular machine. So apart from these security groups and knuckles, AWS also recommends you to have some software firewalls installed in your instances, so you don't compromise anywhere on the security. Again, changes to the knuckles take effect immediately, just like our security groups. Very important for the exam and for the interview. You need to know the difference between security group and knuckles. Any questions that you have in your exam or an interview, you have to think about what is the context of that question and you need to answer them accordingly. Okay. So security group operates at the instance level. So each instance level only, interface level, whereas your network ACL operates at the subnet level. It operates at the whole subnet level. Inside the subnet, there can be thousands of EC2, doesn't matter. But the network ACL applies only on one subnet level. Security groups supports allow rules only. This supports both allow and deny rules. Security groups are stateful. Why it is stateful? Only inbound rules you can define. Outbound rules, it's by default outbound is open. Okay, so you need not write. It implies that somebody comes in, has to go. So if in your house, suppose you are inviting your friend Raj for your house, right? What you will do in the house, outside of your house, you will say welcome Raju, right? So that means only he can come inside. So after he comes inside the house, you don't write go out Raju, right? You don't write that, right? Because it implies that if he comes, he will go out. So that is what your stateful security group is. Whereas network ACL is just like your delivery boy entering your main gate, where the watchman gets the in time and out time. So both, it's a stateless. So we have to write both inbound and outbound rules. Should be explicitly defined. Security group will evaluate all the rule. It will go all the rule to check, and then it will go for the implicit deny if it is not there. But this one, network ACL always process the rules in order according to the rule number. The lower the number, higher the precedence. It applies to instance only if associated with a group. So it will apply to the instance, and this automatically applies to all the instances in the subnet it's associated with. So network ACL, when the traffic comes, it is applies to all the instances, but again it depends on the instance single security group whether it will allow or not, right? Just give me 1 minute. So this is how your incoming traffic works in your network ACL. So right hand side is the subnet. So you attach this network ACL on the subnet and you write an inbound rule. If the rule is allowed, your traffic will come till this, right? Now the traffic will enter your subnet, and your subnet has an EC2. Now if the security groups allows the traffic or on the port, only then this will get into the security group or to that instance. If you are not allowing it here, this traffic will simply just stay being it will just lay around here. That's all. Nothing will happen. Now once you allow in the security group, outbound is allowed by default stateful, so you will get the response back, and here to send the response back to the user, you have to make sure the outbound rules are written in such a way that this traffic can go outside the subnet. So when I do an SSH, I have to allow the SSH. Here I have to allow the SSH, so I can go and reach the machine. The traffic will come outside. If I don't allow outbound SSH, what will happen? The traffic will stay here. I will not be able to log in. I have to allow the outbound rules also, because it is stateless. We have to write both the rules. Similarly for the incoming request, right? Again, this is for the outgoing request. So from knuckle, it will come inside. It will go like this, right? So incoming, outbound, both are same. The direction is different. So now we will go and see how to create a custom knuckle, and we will prove all these things, right? So any questions here, guys, before we kind of go ahead for that hands-on? Please understand this knuckle and security group very thoroughly. You go for any exam, any type of exam in AWS, there will be a question on network ACL, knuckle and related to knuckle and security group. If you are going for any interview for AWS for any position for that matter, whether it is a junior position or a very senior position, you will be asked something around this, both security group and knuckles. Okay, the common use case people will give you is scenario is, okay, you are finding some IP is trying to access your network. Can you go and block that IP? Where will you block? Most of the people will say security group. That is wrong. You can only block in knuckle. Okay, that is the answer the interviewer is expecting. Okay, let's go back. Now let's go to our the VPC that we created, right? See here, this is the main network ACL that is already created for us by default because we did not create anything. So let's go here and see what is that network ACL is trying to do. Okay, this is the network ACL. Okay, it is attached with two subnet. The subnet is both public and private, whatever we had, right? So let's go to the inbound rules, edit this inbound rule and see what is happening. It's a default one. So I told you it's a rule number. So they have put 100, all traffic allow, right, in the inbound rules. Similarly, for the outbound rules, they would have given us all traffic allow. That is why we are able to log in and log out. See, all traffic allow, right? All traffic allow. You have option to allow and deny both in both the direction. Now what we are going to do, we are going to create a custom ACL. So when we create a custom ACL, let's go and see what is there in those outbound and inbound rules. My custom knuckle, right? My custom knuckle. You have to associate this with the VPC. Now, before we do that, so we know that we are already here using the default security group. I'm able to reach my internet. I'm able to log in. I'm able to do everything. Okay, let's just prove that. Okay, yeah, all that is done, and I'm going to come out of this, and I'm able to do a SSH, right? I'm able to do a SSH, right? So that is 22 is allowed in the default knuckle, so I'm able to get inside. Now let's go and create our own knuckle and attach it and see what happens. So attach it to this VPC. So create a network ACL. Okay, see here I have my custom knuckle. Still we did not associate this one with any subnet. Okay, any subnet we did not associate. So let's go and see the inbound rule. Go and edit. This is a custom. Again, please be careful. This is a custom. See, by default all traffic is denied in inbound. Similarly, go to the outbound and you will be seeing everything is denied. See here, everything is denied. Both are denied. You need to define them. Okay, now let's go and attach this to our subnet, right? So that we can go and see whether our traffic is getting denied or not, even though my security group allows, right? Don't worry about that. What this is the first level. Only when you give it here, you will be able to. Now, let me go and select this public. I just have only public, right? Okay, that's fine. Public. Now, this is associated with this. I don't have any rules. Everything is denied. Let's see what happens. So what's happening now? The inbound rule of knuckle, everything is denied. So your 22, your SSH is not happening. Okay, let this be as it is. Okay, now let's go add some rules and see if we can do something. Okay. Now you guys need someone need to guide me to add these rules. Okay. So let's go and edit the rule. Add a new rule. Okay. So as I told you, lower the number, higher the precedence. So it's always start with leave some spacing between. So if I start from 100, suddenly there is another 50 rules you need to write. You can write before 100. Now suppose if we start from 1 or 0, 1, 2, 3 like that, right? 1, not 0, from 1, 2, 3 like that, right? What will happen? If you want to put some emergency rule, you cannot put it in between, right? So we always will start with 100, for example, 100. Okay, what do you want to allow? I want to allow my SSH. Okay, SSH 22 from where? From outside anywhere. Whether you want to allow or deny, allow. Okay, save these changes in inbound. Okay, now let's go and see if we are able to connect. We are still not able to connect because the traffic has actually come inside, right? If you look at this picture, right, you would have noticed now this is allowing 22, so it came inside. My system is also allowing 22, so it came inside. This by default comes outside. Now there is no any rule written in the outbound, so the traffic is not coming out to me. See here, the traffic is not coming out to me, so I am booted out of this. I cannot connect it. So now we need to go and write our outbound rule. Let's go to the outbound rules. Edit the outbound rule and add a new rule. Just make it again 100. Now what should be my rule now here? Can someone say me? We have allowed 22. So 22 has gone inside. It went to the machine. It touched the machine. The response is coming back from the machine. Since my outbound is not allowed, the traffic is not coming out of the subnet. Okay, let's try this. Okay, my SSH, please come outside with this allow. Now will we be able to connect or not? Anyone, any guesses? What happened? We allowed SSH to get inside in the inbound. Okay, it all gone to the system. It came out, and in the outbound also we allowed SSH to come out. But why it is not coming out? This is where there is a big catch there, and you need to understand this. Okay, whenever any traffic is originated from your machine, right, for a particular port, it doesn't go in the same port. Okay, it goes in the same port, and it also has something called ephemeral ports. They are called non-persistent dynamic ports, ephemeral ports, and that port is always from. Keep this in mind. Okay, don't get carried away by just the name. So 65,535, right? So port starting from 1 to 65,535, they are called ephemeral ports. Ephemeral ports. So these are the ports only. You can only have maximum 65,535 ports. So out of which 22 is for SSH, 80 is for HTTP, right? 443 is for HTTPS, like that. All other ports are ephemeral ports. So when I initiated traffic from my system, it will always go as 22 along with one non-persistent ephemeral ports. Okay, ephemeral means non-persistent. Ephemeral port, we have seen this term when we talked about volumes. If you do an instant store volume, they are called ephemeral volumes, right? They are ephemeral, non-persistent. So ephemeral port, it will go with some dynamic port number, and when the traffic comes, it's trying to send to the dynamic port number which we are not allowing. We don't know the dynamic port number, right? What it will come. So what we will do, we have to give the range of IP, range of port numbers through which it has to come. You don't know exactly which one will come outside. It goes as 22, it might come out as 30,443. We don't know, right? So this is where you need to keep in mind. So the outbound rule should always be some ephemeral port. just go to show you knuckle ephemeral ports. Go and search on this one. You can see here in the official documentation about this ephemeral ports, what are these ports and all those things, right? Click on this ephemeral port. See here, many Linux kernels, including Amazon Linux, they uses the port from 32,768 to 61,000. Requesting originating from the ELB, they use the port 10242 to 65,535. Windows operating system through Windows Server from Windows Server 2003 uses 10252 to 5000 ports. Windows 2008 and later versions, now from my system it may be using somewhere between 49,152 to 65,535. It can be a dynamic port, so that is why even they are also giving only ranges. They are not giving anything, right? They are giving only ranges. And NAT gateway will use 1024 to something. Lambda functions will use this. So like this, you can keep on seeing for different things, right? Now you cannot every time go here and check, okay, whether I'm in Windows or whether my user is in Linux or whether my user is coming from there. Here we all don't know all those things, right? So what to do better is always either your user will be coming from either Linux or Windows, correct? So do one thing, always go for 1024 to 65,535. Put this range and you will be able to kind of get this, right? And if you still, because we know if you go 1, 2, 3 and all, right, that will not work correctly. The reason is like all those are small ports, like 25 is used for your SMTP, and ICMP protocol uses one port, right? All those guys use different ports. So they all comes before 1024. So what we are going to do, we don't know the dynamic IP. I will show you in the next, when we learn something about the logging of your traffic, network traffic, we will see the actually dynamic port which we are coming out, right? We will be able to see that, but that varies from every time. So you cannot define that. So let's go and start from 1024 to 65,535. Copy this, go to your outbound rule, edit your outbound rule. Okay, now here you need to say this custom TCP. Whenever you give custom TCP only, you can give a port range. If you specifically select some protocol, say for example, if you select this SSH, by default it will be 22. Okay, so we have to say custom TCP or custom protocol, whatever it is, right? In custom protocol, there are a lot of protocols. Better to go for custom TCP because we know it is a TCP. And just go and say this range. Okay, 10242 to 65,535. Now let's save this and see if it works, right? See, the inbound is 22 only. Okay, inbound is 22. When it's outbound only, you get the dynamic port. See, we are able to now log in. Any questions here, guys? Please get it clarified. Okay, so this is your inbound rule and outbound rule. Okay, see here in outbound we will have custom TCP and allow between this port ranges from 1024 to 65,535 because as per the documentation, your Windows 2008 and later, mine is somewhere. See, actually still if you give specifically Windows, it can be this one, but we don't know, right? Our customer can be either in Windows or Mac or whatever it is. So it's better to go for 1024 to 65,535. So it can be any port between this. It can be any port between these two numbers. So this is what we are able to do it now. Now let's see how this number thing work, right? So let me come out of this. Let me come out of this. Now we are able to log in with this. So what is happening now? If you see, your inbound rule 22 is allowed. Here also 22 is allowed. So this guy automatically comes out. And here the ephemeral ports are defined. So it carries a dynamic port. So it knows within this port range. So one of the number matches within this range and you are able to log in, right? Earlier, we just gave 22 and we gave only 22 here. We are expecting that outbound also will come in 22, which is not the case, right? Which is not the case. That's what we found out. Now let's go and see how we can see this preferences of these numbers, right? So we have 100. Now the recommendation is if you want to write the next rule, always the recommendation is to leave some good spacing between the numbers. So 110, that means you have 9 rules you can write between 100 and 110 if you are going to do, right? So that is another thing. Now let me do one thing. Okay, this is outbound. Let's go to the inbound first. Yeah, this is the inbound rules. So what we are doing, I told you SSH in 100 it is allowed. Let me add a rule, say in 101, okay, in 101, okay, I'm denying this traffic. I'm denying SSH in 101, okay. So as we told you, higher the number, that should be take the effect. So it should allow. Let's go and see. Okay, deny that. Save these changes. Okay, I'm just only talking about inbound. Go and do this. So 100 is allowing, 101 is denying. So the lower the number, higher the precedence. Now let's change the number. Let's change the number or add another rule in the inbound, and I'm going to say add a new rule and say 99. 99 is less than 100. Okay, so 99 SSH deny. So it will go as per the number. Now you go try to access it, right? Same thing. Inbound is now denied in 99. So lower the number, higher the precedence. So 99 is lower than 100 or 101, even though you allow in the next one, right? So this is how this number thing work. So in knuckles are, it will evaluate the rule based on the numbers and it will go order by order. But the lower the number, higher the precedence. So even though you say allow below, right, still it will deny. And even if you allow in the first and do a deny in the end, still it will allow, because the lower the rule number, higher the precedence. Okay, keep that in mind. So this is how it works. So go and do a edit inbound rule. And now if you want to allow this, either you're going to change that to allow, or you can say rule number 2, right? Rule number 2, go ahead and SSH, you allow me, right? See, there are multiple rules now, right? Think about this logically, right? See, it is already ordered by number. Even though you added in the end, it will order by number. So first the rule will come and check here, rule number, where is SSH? Here is SSH. What is the rule number? And the first encounter, whether it is allow or deny, will take effect. Okay. Now go back. See, we were not able to connect because 99 had deny. So I just put a new rule 2. We are able to allow. So lower the number, higher the precedence. It will evaluate in order, and then the first, if it encounters, wherever it encounters first time in that number, if it is allowed, it will allow. If it is denied, it will deny. Irrespective. Okay. Any questions here, guys? You need to understand this. If you have any queries, please let me know. So this is how it works. It's the same rule, SSH, right? So again, all this is dependent upon how we are writing this rule. Now, if I would have written as 1, 2, 3, right? I will not have anything to do on the above this one, right? I cannot kind of do the a rule. I need an emergency rule. I cannot do. Let's go and see how to block our IP, right? To find out to block our IP, what we need to do, I need to find out my public IP. So that means only assume that my IP is causing some issue in your network and your manager is asking to block it. Let's see where to go and block it, right? For that, I need my IP. So to just get your IP, it's very simple. Either you can go to a site called what is IP. There also you can go what is IP. What is my IP address? This is a site. So it will simply take a lookup and give you your IP address. Click on my IP. This is my IP, your IP. I mean, if you log in, it is your IP. Okay, so this is my IP. Let's find out if this is the correct one. 115.99.3.3, right? Go to a security group. Go to any security group. Go to any security groups. I'm just selecting something. Go to an inbound rule, edit some inbound rule, and add a rule and say my IP. See here 115.99.3.3, and as I told you, a single IP will always be represented as /32 because 32 minus 32 is 0, 2 to the power 0 is 1, so it's a single IP. So this is my IP 115.99.3.3, right? So you can go and find out like this or like that. Okay, that's fine. Now assume that your manager is saying this IP is having some issue, you need to block this IP, right? We'll see where and all we can block, right? Now if you go back to the security group, right, same thing in the security group, we can only do an inbound. Go to edit inbound. You can never do a deny. There is no deny here, right? Only whatever that you do here will allow you. It cannot deny, so you cannot write it here. The only way to write it is go here and add a rule and say 1 because already 2 is there. 1, okay, SSH. So whenever you get anything from this IP, please block this guy. And how you will put that? You have to put it as /32. Okay, that's a single IP, so /32. So from this is my IP, so you always deny any traffic that is coming from this guy. Go and deny from this particular IP. So this is my IP. Now I'm trying to go ahead and see what is happening. Since the traffic is coming from my IP, already the rule number 1 is there, which is on the topmost. It says you deny the traffic for 22. I'm trying to go as 22, right? So this is how you block your specific IP or even the IP ranges, right? Now I've just given /32. Suppose you want to block the company, some company's network, you have already had some contract and now you have kind of the contract is over or you have left them out. So you don't want any of their people to connect to your machine and they have an IP range, say 10.1.0.0/20. Go and put that there. Anybody who tries to log in within those number, right, like say 4096 IPs, they can never get inside your AWS environment, right? So this is how you can go and block a specific IP. Block a specific IP. Okay, so you can have allow, deny, you can do all sorts of things here. Okay, this is a single IP. You want to give a different IP, you can go give a different IP and it will allow you to block this. Okay, this is what I told you. You have to do this hands-on and check, only then you will be able to answer these questions correctly. Okay, that's fine. Anything on knuckles and this one, guys, before we move to the next one? It's very important. You need to understand this. If we don't get this right, it's going to be very difficult. So what I'm going to do, I'm going to make this as all traffic allow. All because I'll be using something else also, right? All traffic allow. Save this changes in inbound because we have to use this for some other things now. Go to outbound and edit this outbound, and instead of this one, just put all traffic. So all traffic, all port range will be allowed. Okay, that's fine. Just like our default knuckle subnet association. Let's edit the subnet association and also check both public and private, so everything is allowed everywhere. Okay, so just to check, make sure, get inside, you should be able to get inside, right? And if you need to get into the public machine also, go to the public machine and see if you're able to get inside, because the same knuckle is applicable for both public and private subnets. This is our private machine. We are already inside the private machine and I'm able to ping Google because of the NAT gateway. Okay, so all this is fine. Now we are back to the same setup wherever we were before doing the knuckle. Okay, now this is over. Now let's go to the next concept. Okay, any doubt here, guys, you have before we move to the next one? Okay, so next is we have to do a peering, right? So what we mean by peering, I told you yesterday, when you have two apartments, if you have a mutual understanding, you can have an internal gate privately moving from one apartment to another apartment. Okay. Similarly, peering, VPC peering is connecting two VPCs privately using AWS network. That means you don't have to come out of your main gate to get into the other apartment next to you, right? Unless you have a mutual agreement, you can have a private way to access it. So why you need this VPC peering, right? So in a company, you may have multiple VPCs, multiple applications running in multiple VPCs, and you may need to leverage some of the resources in both the places. Then you need to kind of connect them using VPC peering. Make them behave as if they were in the same network. Very important criteria for two VPCs to get peered. So this is also an interview question. So what is the eligibility criteria? How you will evaluate that whether these two VPCs can be peered or not? So say they'll give you a situation saying that your manager has given you two VPC, VPC A, VPC B, and he's asking whether we can peer that or not. Okay, why? If you say you cannot peer, you should give the reason why you cannot peer. Then you need to say if both the VPCs are having the overlapping CIDR block, then it cannot peer. Both the network ranges should be different because we need to have entry in the route. You cannot have duplicate entries, right? So that is the reason. So if VPC A is in one network, VPC B should be in another network range, so that they don't both overlap, so you can peer them. VPC peering connection is non-transitive. That's very, very important. Keep this in mind. It's non-transitive. That means if you are having VPC A and you are peering with VPC B and B is peering with VPC C, it doesn't mean that A can peer to C. Okay, so it's just like having our friends, right? If friend A is equal to B and B is equal to C, then by logically A equal to C. That is transitive. But actually VPC pairing is non-transitive. You need to have an explicit connection for each and everything. So A to B you need to have one connection, B to C you need to have one connection, and also A to C you need to have an explicit connection. Otherwise A cannot talk to C. Okay, so that is why it is called VPC pairings are non-transitive. They are not transitive. Okay, they are not transitive. Keep this in mind. They are not transitive. They should not be having any overlapping CIDR block. You can do VPC peering with either the same account, same region VPC, same account, different region VPC, or with your account with other region in the same other account, same region. So account A, account B, both in Northern Virginia, different VPCs you can do, or another account, another region VPC also you can do. You have some 4 or 5 combinations there. Okay, so you can peer with other account also. So suppose you have a partner company where they are having their resources you want to leverage, then you have to get their account number and you can peer with them, and it is as if that they are inside your network. Very important, you must update your route tables in each VPC subnet to ensure instances can communicate with each other. Instance can communicate with each other. Okay. VPC pairing can work in inter-region or cross-account. So we saw that it can work this way and that way. You can reference a security group of a peered VPC, work across accounts. So you can use a security group from another account like this. This 1, 2, 3, 4, 5, 6, 7, 8 is an account ID, 12-digit account ID of another account. So this is a security group of another account. You can use that in this way. So how to calculate the number of VPC? This is how you need to calculate the number of VPC. The formula is n into n minus 1 divided by 2. N into n minus 1 divided by 2, where n is your number of VPCs. So now you do the math, right? Now I have 10 VPC. So it's going to be 10 into 9, 90 divided by 2, which is going to be 45. So if you want to peer 10 VPCs, you need 45 peering connections, which is very, 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 very tough to manage. So in our case, we have 3. What will happen to 3? 6 by 2, you have to have 3. That's why you have 3 connections here. See here, the 1, 2, and 3, right? So this is how, this is a calculation you need to keep in mind. N into n minus 1 divided by 2, where n is your number of VPCs. So suppose you have 5 VPCs, then you need 10 connections. You need 10 VPC peering connections. Now it's going to be very, very difficult to manage this mesh because it's going to be something you need to change in the route table, you have to change all the 45 places, right? So many things will happen. In order to overcome this, the advanced they have come advanced networking. They have come up with something called TGW. It's called Transit Gateway. Transit Gateway. Transit Gateway. So this works like your, say, suppose you have a in your house you have a power. You wanted to take power for your laptop, mobile. What you do? You go out and buy a spike, right? There is a spike. So where the source of that spike you can plug into only one place, and the current comes and diverts into all the other plugs, and you can plug into those things, right? That's called a spike. I think you would have in your house a spike, or they call it a flex box, whatever you call it, right? So that spike is nothing but your TGW. That one spike is TGW, and you can plug in multiple VPCs into that, and it will all interact with each other. So one transit gateway can be able to communicate with multiple VPCs without using VPC peering. Okay, so this is just like using our spike for the power source. Okay, spike for the power source. Okay, now how are we going to demonstrate this? Like, let's go and see how we can demonstrate this. So in our picture, this is the place where we are trying to do a peering. This is a VPC. This is another VPC. We have to peer with this VPC and this VPC and see if we can ping from this EC2 to this EC2. For that, what we are going to do, already we have a VPC, custom VPC. We are going to create another VPC called VPC B. VPC B, and we are going to create one EC2 there, and we are going to try to ping from here to there without peering and with peering, right? That's what we are going to do. Okay, for that, as I told you, we will need to create a VPC. Again, this CIDR block should not overlap. Okay, I'm having 10.0.0.0.16 as my this source VPC. Let's create another VPC called VPC B. Okay, and this CIDR cannot overlap with that. So the transit gateway is used to kind of a hub and spoke model, right? As I told you, like we have a spike. So what will happen is you don't have to create a VPC pairing across all the VPCs. So using a transit gateway, you plug all the VPCs into the transit gateway, and then the VPCs will be able to talk to each other by just creating only one transit gateway. Right? So it allows you to connect to your VPC from your on-premise also just by using one transit gateway. So we have to have a different range. So this is a different range again. See here, it starts with 10.1, whereas that VPC starts with 10.0. Okay, entirely it is different. Scroll down. Let's create a VPC. Let's create a VPC. Make sure you enable your host name so that your DNS can recognize your machines if there is anything is there. Now that is fine. VPC B. Go to subnet. Create a subnet, and this is for VPC B, and this is a CIDR range. So my subnet will be I'm going to make it public subnet B. Okay, public subnet B. Everything will be ending with B, so we know it is that one, right? And my CIDR block will be 10.1.0.0/20. Okay, just going to create only one. Okay, my public subnet. Okay, my public subnet. So what you can do, okay, we don't want to have any we'll try to only ping from here to there. If you want to do ping from there to here, then you need to have all this public subnet as your public IP and all those things, right? Otherwise, just leave it as it is. We just ping one way and just confirm. That's all. Okay, it's fine. And we need to create a route table. Public RTP, and select this one for B. Go and create a route table. After create a route table, we have to associate this subnet with the route table. Edit subnet association and select this guy and save it. Now what is happening? You are not having any public internet, nothing, right? So this is if you are going to launch something inside this, it will actually have only the private IP. Okay, so let's go and see if we can launch one mission here inside the B and see what is happening. So I can say, is it my EC2 VPC-B, right? EC2B. Now scroll down, all this is fine. Now key pair. I'm not going to log into that one, so just going to only ping. So let's proceed without a key pair, and I have to make sure that this is inside VPC-B, and there is only one subnet, so no issue. Let's go here, and the security group. What we will do, we will, instead of doing SSH, I cannot SSH, so I'm going to do all traffic allow. So if I try to ping, it should be able to ping. Let's launch this instance. You can never connect to this instance now. Okay. Go refresh here and see here EC2B. You will only have a private address 10.1.12.22. Now let's get into this one. Let's get into our my custom VPC, the public, this one. So now if I'm trying to ping this IP, there is no peering, nothing now. We're just trying to see if we are able to ping this, right? Go here. We are not able to ping. That's fine. Just before that, make sure your public EC2 here, the security groups are having all traffic allow, right? Otherwise, we have to allow, because ping works in different protocol, different port number. So we just need to double check to make sure. See here, it's only allowing this. So let's make it as all traffic. All traffic, and save this rule. Okay, now you go ahead and do the ping again. You cannot do a ping because both are different VPCs, entirely different VPCs. Now we are going to create a peering, and we are going to have a route entry, and then we will see whether we are able to ping the mission from the other VPC. So for that to do, go down, you have a peering connection. Click on peering connection under the VPC section. Okay, create a peering connection and see, give a name for this. Okay, my peering, whatever name that you want to give, right? My peering. Now, so this works on a requester and acceptor. So some VPC will request, some VPC need to approve and accept that. Only then it will be done. So for our case, my custom VPC will be the requester. So this is the signer associated with my custom VPC. And whether you want to select another VPC to peer with in the same account, same region, another account, same region, my account, another region, another account, another region, right? So these are all the combinations you have. So it is now, for me, it is a my account, it is in the same region, right? That's why you are able to see this here. Go and do a VPC-B. See here, 10.0, 10.1, it doesn't overlap, okay? If you would have had the same, it will not allow you to peer. That's all. Just go and say, create peering connection. Once you get peering connection, the acceptor party needs to accept it. Since both belongs to my account, it's just very simple. I just need to go and do a accept. If we would have done with a two different account, so the account B, whomever is the receiver, they have to go and approve this. You have 1 week time to approve. See here, you can accept or reject this peering connection. Action window, you have until Sunday, 14th, 2022, which is almost a week's time to approve or this one. Otherwise, this request will expire. Okay. Let's go and accept this request. And it'll ask you, okay, who is the requester, who is the acceptor, and these are all the details of that, right? Who is the owner and all those things. Verify that and go ahead and accept the request. Once you accept the request, and go to the peering connection, you will see a peering connection that starts with PCX, right? PCX. Now, just like our NAT gateway, in the route tables, we need to say, okay, whenever I try to see here, even though we connected, still the routing table doesn't know where to go, right? So what we will do, go back to the route tables, go to the public RT route table because we're using that machine from there, and go to the routes, edit the route. So already you have a local route. So anything within 10.1 will go, but I'm trying to connect to 10.1. So let's go and say 10.1.0.0. So anything, right? Any traffic that goes to that machine needs to go through my peering connection. That's it. Go through my peering connection. Save this. Now this is alone is not sufficient, right? Still we will not be able to ping because it's only one-way traffic. Now there we need to write, see, always this ping works like this, right? There is a ping request will go to that machine. There should be a reply from that machine. So you need to have an entry there also saying whenever the destination is that particular machine, go through peering, right? Go to the route table, the route that we created in B, the route we created in B, go and put the route and put an opposite one, right? So by default 10.1.1.0, it's a local. Add that anything comes from destination is 10.0, right? The opposite one, 10.0.0.0/16. Okay, please go through the same peering connection that we have, right? This is the peering connection. And save these changes. Go back and see it started pinging now. So we have now peered our two VPCs, my custom VPC and VPC B. Now I have a machine in the VPC B. I'm able to ping there. Now if you would have logged into that machine, you will be able to ping this machine also, right? So this is how it works. You get it now, right? So after we do the peering, we have to make sure the routes are entered correctly. Then you will be able to peer. So I'm pinging from 10.0, the entirely different network. 10.1 is entirely different VPC. This is VPC B. This is my custom VPC. Any questions here, guys? Okay. So this is how we do the VPC peering. Okay. Any question before we move on to other ones? Okay. Let's move to endpoints, right? As we told you, endpoints allow you to access your AWS resources using private network instead of going over public network, right? Going over internet. Instead of going over internet, we can go and access our services using the private network. So endpoints scale horizontally and are redundant. They remove the need. So if you have the endpoint, you don't have to have the internet gateway. You don't have to have the NAT gateway just to access any AWS services. Only if you want to go outside the internet for something else, then you can use all those things. So there are two types of endpoints. One is interface endpoints and gateway endpoints. All the services are using interface endpoints, which use the ENI, which will use the Elastic Network Interface as an entry point. So you must attach some security group. But whereas the gateway, we have only two, S3 and DynamoDB, they are all global endpoints, gateway. So we are going to talk about gateway endpoints. We will see how we can touch S3 via internet and without internet, right? So that's what we are going to see. And now, recently they have changed the S3 and DynamoDB also to interface. So you have both the options for internet interface gate endpoint and gateway endpoints. So let's go and see what we need to do. Before that, we need to create a bucket and see how we can access it through internet, right? That's what we need to see. So before creating the endpoint only, we can prove that it is going through internet. Let's go and see how to create that, right? So what I'm going to do, I'm going to create a S3 bucket. We already saw how to create an S3 bucket. Let's go and create a bucket. The bucket name should be unique. So I just add some random numbers. I'm not going to have anything in this bucket. I'm just going to only connect it. Okay, nothing else we're going to do. We're just going to list the bucket. Okay. If you remember from our first class when we talked about IAM, users, groups, roles, and policies, I told you when two services need to talk to each other, we have to create roles and attach it, right? So now we are going to try to access this bucket from EC2. So EC2 is a one AWS service, and your S3 is another AWS service. So when these both services need to talk to each other, we have to create a role and then attach that role to EC2, then they both will be able to talk. So what we are going to do, we are going to create a role. Create a role in IAM. Okay, create a role. And what role you want the AWS services to assume this role, not any other account or web identity is nothing but your Facebook and all those other things, right? Those things, right? Whether you want or any other SAML federation or custom trusted policy. Right now, our EC2 is going to access this S3. So common use cases will be always EC2 or Lambda. That is why it is listed here, but you can select all other services here. Okay. Do a next. What are you going to do? You need to attach a policy. So I wanted to attach S3. Sorry. Filter by. Go select your managed policies down. Amazon S3. Okay, Amazon S3 full access. So either you can have read-only access or whatever access you want to give. I'm just giving a full access. Let's select this managed policy. Next, give a name of the role. So today's date is 0807 EC2 S3 role. That is the name that we are giving. Okay, just scroll down. Who can access this? See here, this is very, very important, right? STS is secure token service, secure token service, and it will, there is an API called assume role that will be assumed by EC2. So EC2 can now access the, it will assume this role, and then it will connect to the whatever permissions are there, it will add that, so that your S3, it can access your S3. So go and create this role. Okay, once the role is created, review all those details and say, just say go to the end and say create role, and your role should be created. Go here, your role is created. Now how do we attach this role? After you create an EC2 mission, okay, after you create an EC2 mission, after you create an EC2 mission, so I'm going to attach this role to the private instance. Why I'm going to attach this to private instance in my custom VPC? Because private instance goes through NAT for internet, right? So we can prove that we can remove the NAT and check if it is going or not, right? So that's how we are going to do. So let's go to the private EC2, select this private EC2, go to actions and go to security and say modify IAM role. So either you can set up the role while you are creating the instances, or you can come back and do this also, right? Go and select 0807. You will get this role here, see, and just go and say update IAM role. Okay, now where are we? We are in 10.0. Okay, fine. We are now back to wherever we are. Now let's go and do a SSH to the private instance. We are in the private instance. The role has been attached. Now what we are trying to do, we are trying to access this S3. So AWS S3 LS. If you do this, see, from private instance. So this is our, I'll show you this. So what's happening for your endpoint? Okay, from this private instance, there is an S3 bucket outside. So what I'm doing, I am using this bucket, this EC2 machine, going through the router, going through the NAT, going through internet gateway to access my S3. That is where this one is you are able to access the bucket. Okay. Now what we are going to do, we are going to remove the entry for the NAT gateway, so it doesn't go to internet, right? It will not go to the internet. So for that, what we can do, just go back to the route tables and go to our private RT. Go to the private RT and go to the routes and edit the route, and now remove this guy for not this. Go to the private RT. Go to the private RT routes and edit the routes, and here you have NAT gateway. Before that, let's make sure like everything is working through internet, right? Go and do a ping Google from here. You should be able to see you are able to ping Google here. All that is fine, and you are able to access your S3 because it goes through NAT gateway using your internet. Now I'm going to remove this, right? I'm going to remove this rule and save these changes. Now go back and try to access your S3. Nothing will come because there is no internet. So what we are going to say is we are going to create a private endpoint, and then using the endpoint we can access the S3 bucket without internet, right? That's what we are going to see. So just to prove that it is going through internet, we have done this. Now we have removed the NAT gateway, so there is no way that it can reach the internet now, right? Not only this one, right? You can check for your Google also, right? Even if you ping the Google, everything is stopped. Nothing will happen. Okay, now let's go back and create this endpoint at whatever that we are talking about, right? Go to endpoints, click on endpoints and say create endpoint. Okay, you can give your name of your endpoint, whatever you want. My endpoint will be used by AWS services, or you wanted to talk to a partner service, you can talk to another service or a marketplace services or any other endpoints that you want to use. That with this AWS you can use for on-premise also you can use. So these are also we are going to do the services that are provided by Amazon. If you click on this one, third party, it will ask for different things that you need to get from them, and you need to keep configuring them, all those service names and stuff, right? And if you are putting this marketplace, then through the marketplace you can do that, and you need to go and get all those services from there. And if you're doing any other endpoint, you just need to enter the endpoint and you need to enter the service name and we need to verify. Okay, let's do this. Now I wanted to go and access this one, right? S3. So as I told you, S3 has a gateway endpoint and an interface endpoint. So we will select the gateway endpoint, so you need not attach your security groups and stuff. And which VPC you wanted to select, it's a my custom VPC. Once you go to the my custom VPC, it will ask you which route table you want to associate this, because when you create an endpoint, an entry is added automatically to the route table, which you cannot delete. If you delete the endpoint, that entry will go. So you cannot delete or edit. So you need to select the appropriate route table where it needs to put the entry. So this is the place it has to put the entry, and this is the policy where you want to say who can access this endpoint. So it's full access, so everybody can access it. And go ahead and say create endpoint, right? Once the endpoint is created, again make sure you cannot ping Google because we are not going through the internet. Okay, we have created a private link to access our AWS S3. Let's go and see if we are able to access it. See here. So it is not going through internet. We have created an endpoint, and privately it can access your S3 bucket, right? So that's what is happened now. So now quickly go on the top of this page just to show you where we are right now, right? Here is where we are. See, can you see my this one? Okay, here is one we have, right? So here is where we are having the endpoint. We have created the endpoint from endpoint, you're able to access the S3 bucket. Initially, how we were doing, we were going out like this and coming and reaching out to this. Okay, so this is what is the difference between what we saw now and how we created our endpoints. Now let's go back to our private route table and see if that entry is there, right, for the endpoint. Go to the private RT, go to the routes, edit the routes, and see there by default there will be one entry for your VPCE, that is VPC endpoints. You cannot delete, you cannot edit. Okay, a route, that's why we select the appropriate route table for which the entry needs to go inside. Okay, so this is how you create an endpoint and access all your AWS services privately. All your AWS services privately. Any questions here, guys? Before we move to the next one, we are almost close to done. We'll close off VPC today. Okay, just hold on for 5-10 minutes. We'll be closing off VPC. And so we saw this VPC peering, and we also saw our endpoints. And now let's talk about flow logs, right? What are flow logs? Very important, right? So flow logs will help you to capture your network traffic that is coming in from outside to your subnet, right? So you can capture information about IP traffic going into your interfaces. So there are 3 places that you can enable your flow logs. You can enable at the VPC level, subnet level, or the ENI level. So when you do at the ENI level, that is Elastic Network Interface level, it will monitor the traffic for only that particular machine. If you do at the subnet level, it will monitor only for that subnet. If you do at the VPC level, all the traffic that comes inside any of the subnets will be monitored. So we are going to enable it at the VPC, and we are going to see what are the different things are coming and who is trying to do what, right? We have a lot of public systems, and let's see if somebody else is trying to access our system. And here is where we can see our ephemeral protocol that it is trying to come out, right? That also we can see here. It helps to monitor and troubleshoot any connectivity issues or network issues. And one more thing you can do, this flow log data, you can put it into S3 or CloudWatch logs, another service, and you can do some insights from there. So it captures the network information from AWS managed interfaces like Elastic Load Balancer, RDS, Cache, Redshift, Workspace, and all the other interfaces. It can capture the log. So this is the syntax that we have. So this is the version, account ID, interface ID, source address, destination address, source port, destination port, which protocol it is coming, how much packet is coming, what is the size of the packet, when start and end date and time, action, whether it is accepted or rejected, your connection is accepted or rejected, and log status will always be okay. If this particular line is logged, it will put okay. So very important thing we need in this is the source address, destination address will help to identify problematic IP. Similarly, source port and destination port will help you to identify problematic ports. Action, success or failure of the request due to security group or knuckle. If your security group knuckle allows, and we have now allowed everything, so everything will be mostly accept traffic only. Okay, then we will change that 1 or 2 to reject also, and then we will see. Can be used for analytics on usage patterns or malicious behavior, right? And you can also query this flow logs using Athena, a tool called Athena. Athena uses the normal query language like SQL, right? And you can go through this flow logs example you wanted to see something. Okay, let's see how to enable this and how we can see this, right? So before we enable flow logs on the VPC, right? Let me show you how to enable this flow logs. Just to see where are this, right? Click on this My Custom VPC. See here, there is a tab called flow log. You can create a flow log inside this one, or go to your subnet. I told you we can set it in the subnet level. Go here and you can create a flow log here, or go to your machine. Not machine, actually it is your, what is your this one? It should be your ENI. It works in the ENI level. So if you go to this ENI, right click and open in a new tab, you will go to that Elastic Network Interface. If you go to that Elastic Network Interface specifically, you will be able to enable the flow logs. So these are the 3 places where you can enable the flow logs. If you enable in the ENI level, it will only watch the traffic or capture the traffic only for that particular machine. If you enable it at the subnet level, it will monitor only with that subnet. If you are enabling at the VPC level, it will monitor all the traffic that is coming inside all the subnets and all the systems. Okay, just keep that in mind. And with that, we will go back and try to enable this in our this one. Okay, so for the flow logs to happen, we need to create some. Okay, we'll use this flow logs role. Let's go and see what is inside that flow logs role. So you will be able to see this, right? So this is the JSON file that we have. So what it will do is basically it will allow to write and create some log groups and streams into your CloudWatch service. Okay, we'll talk about CloudWatch later, but that's a logging and monitoring service. So you are allowing your VPC to for these actions like creating a log group, creating a stream, put log events, and all those things you are allowing. That's all, nothing else, right? So we will use this flow logs rule to attach there. So go here. And before we do that, just go to this public EC2 and go to security and right click on this, open this in a new tab. For the inbound rule, what I'm going to do, I am going to allow all traffic only from my IP. Okay, so all other IPs should be rejected if any traffic is coming to my public machine. Okay, that's fine. Let's just only keep this for now. Now let's go back to our VPC, select your VPC, and before you kind of select your flow logs, you need to go to the service called CloudWatch and create a flow log group. That doesn't create automatically. You need to go and do that. Go to CloudWatch. Click on CloudWatch. Don't worry about CloudWatch. We'll have a separate section for CloudWatch. Go to the log groups and create one log group, and we will use that log group there. So create a log group. When you create a log group, you can give flow logs group, right? Retention, whether you can say never expire or you can give some expiry date, right? When it will expire in 1 day, 2 days, 5 days. So we are going to delete this, so we'll just leave this as it is and just come down and just go ahead and create this. Create a log group, right? So this is flow logs group is what we are going to create. Now go here and enable your flow logs. So create a flow log for this custom VPC. Name of the flow log, say my flow log. It's just the name. Whether you want to filter all the traffic or only accept and reject. I want to filter all the traffic so I can see what is rejected, why it is rejected, from where it is coming, right? And aggregation level, whether it has to send the logs to the flow log after 10 minutes or 1 minute, right? So it will wait for 10 minutes to aggregate the log and send it, or we can put it as 1 minute so we can get it immediately. Send the logs to CloudWatch logs. Yes, it will send it to CloudWatch logs, or you can send it to Amazon S3 bucket if you need to store it in a bucket for later use. Refresh here and you will see the flow log group that we created. Select it here, and the IAM role that we were trying to add is your flow logs rule. Flow logs rule. This IAM group should be there. If you don't give this rule, then it will not work. Okay, whether you want this, we saw this, right? Version, account ID, interface ID, source address. This is the custom default format, or you wanted any custom format, you can go and select these many attributes we have, and you can go and customize however that you want, right? So we will go with the custom for now, I mean default one for now, and then just go down and say create flow log. Okay, once the flow log is enabled for your VPC, see here flow log has been enabled for this VPC. Just wait for some time and let's go and do a SSH into this machine. So we create some traffic for this one, right? Okay, we have a problem here. The reason is we have changed that only from my IP when this one was logged in with other IPs, right? So let's go down, take this public IP, copy this public IP and see if you are able to. Go to downloads where my key is, right click and go to git bash here and say ssh -i 0201.pem, then ec2-user, and remember we are only allowing SSH only from my IP, all the traffic from my IP. Okay, we are inside now, all that is fine. So we are creating some traffic there, let it create. Now go back to your CloudWatch, go to the flow log group and wait for it will create a stream. See, it's already created a stream for us. This is the ENI, this is the machine that we try to log in. So it is going for both 93 and B4, right? What is B93 and B4? If you go here, go to public EC2, go to the networking. You can see the ENI here. That ends with B93, right? So B93 and another one. So this is a public machine. This is this one. Click on this one. It will log all the details. See here, it's all reject, 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 right? It's only one is okay. Let's take this okay and see what is happening. What is this okay, right? Let's copy this and paste it here. We will just go and decode this and see what is that, right? Before that, let's also take the default one that we have, right? We'll go decode this, copy this, go back on the top and put it here. So just compare on the top. Okay, compare on the top, so you will be knowing what we are trying to do, right? So the first one is the version. Okay, the second one is your account ID, the third one is the interface ID, the fourth one is your source address. This is your source address, and this is your destination address, and this is your source port. See, it's coming in 5002.2, and this is your destination port. Then this is your TCP protocol. TCP 6 is always protocol. TCP 6 protocol number is 6. One packet it has sent. It is 40 bytes. The start time is this one, timestamp. The end time is this one. Whether it has been rejected or accepted, it is rejected. Whether this particular line has been logged into the log or not. Yes, it is done. So we are very much worried only about this port. Now let's try to see what is this, right? So this is a source address. Somebody is trying to access our system. What is this? This is our destination 10.0227. What is this 10.0227? If you go and see here, this is my public machine. 10.0227 is what they are trying to reach over the source port. From this port, it is coming to try to reach the 23, right? Who is trying to reach, right? I don't know what this IP is. Let's take this and go to what is my IP. Go to an IP lookup. Go to IP lookup. Click on IP lookup and put this IP here and see who is trying to access our machine. Since we are on the public network, so somebody from China is trying to access this our server. So that means somebody physically sitting there? No, it may be some script that is running that is trying to do this, right? Okay, so this is how you can do. Now this is a reject. Now let's go and see what is accepted, right? Okay, there is, let's go, all these are reject. Okay, it's fine. Refresh here. If there are no data, it will skip those things. Okay, this ENI is not the one that we are looking at. So the ENI that we wanted is the other one, I believe. Okay, let's go to 93 and see if we can filter any. If you can see any accept here, right? This is the accept. Now copy this one. Okay. Similarly, go down and see this is the accept is okay. Now again, this is the version ID and this is your account ID. It's fine. This is your account ID. This is the network interface that where you are going. And see here, this is my source address. 115.99.3.3 is my address, correct? So that is my IP. So there is no doubt about it. That is my IP. So it is allowing only me to go. See, 115.99.3.3, right? 3.3 is allowed. And where am I going? I am going inside this. Now, what is my source? See, my traffic is originating in 62,867. That is the ephemeral port that my traffic is going from my machine. I told you, right? We'll have from 1024 to 65,000. So it is going in 628, 67. It is going and reaching the port 22, which I already have access. And these are all the this one. And it has accepted to OK because we have written the rule. Anything comes from here alone, please allow. Otherwise, what will happen? All the other traffic will get inside. Okay. So this is how it happens. Okay. So now you can see how the traffic goes. Now, if I go and exit here and go and do this one again, now the ephemeral port, the dynamic port needs to change again, right? It may go to some other port. So unless you kind of do this and watch for yourself, you will not be able to understand this. But again, it will be quite interesting to see what are all things happening, right? Who are all trying to access your system. What are they trying to do, right? Everything you can see here. Okay, you can also filter events by say accept, reject, and all those things, right? Scroll down. It's the same this one, just keep refreshing. So each stream will be a this CNI, let's say B93. It might create multiple streams also. Okay. Okay, so you may have something accept, reject, and check for accept. Okay, there are two accept here. Both are coming from my IP, and this is what we had. Okay, just wait for the next this one, right? Traffic to flow. It has to aggregate all the logs for a minute, right? Only then it will hold you. So you can go and see, right? Any rejects, right? Any rejects you can go and see. Somebody from this system is trying to come inside 61,000 and trying to attack my port 110, but I did not open 110, so it is rejected. If I would have opened all traffic, what will happen? Every reject will be accepted. So they will be able to get into my system. They will do something. They will be able to get outside, right? They can do all sorts of things that they want. So this is IP. Someone is trying to come through 34,411 and targeting my IP 2052, right? So this IP, let's take this IP and see who's this guy. That one we saw from China, somewhere from China. What is this one? I don't know. Let's go and check. So now here is where you will try to find out. See, this is from somewhere, I don't know where is this. From US, right? From US, Michigan. You'll also get a latitude and longitude. This is how your cybercrime police will try to find out that you have browsed from your house because of this IP databases, right? Using the IP, using my IP. Say, for example, I have my IP, right? So this is my IP. Let's go and see where is my house, right? This is how all your cybercrime police will try to crack the case, right? If somebody is doing something over the internet. So we need to be a little bit careful when we are doing anything with the internet. So this is IP. See, this is my latitude and longitude. I'm in Chennai. See, it basically gives the location of my house, almost the location of my house. So you can click on this wherever that you have, right? I don't know, maybe it takes to my house. I don't know exactly. So you can go and check on this one. Okay. So like this, they will find out using this latitude and longitude, and they will pinpoint your exact location. So you will also get to know who from where they are trying to access. Even though this one, see, I'm using a Hathway, so my ISP is Hathway, but of course it doesn't give my address here. So this is the where exactly from where this location is coming, right? Latitude and the longitude. So this is how we can find out. And you remember, like whether to block any specific IP or not in the knuckle will be decided after watching this one continuously. Your network engineers will keep monitoring this one. If somebody is from this IP address continuously trying to poke our network, then we will block this range, right? That's what we will do. Okay. Any questions here, guys, for flow logs? It's very simple. It's very simple. Only thing you need to enable and try to play around and check, right? Okay, fine. So this is on your flow logs. Then we talk about something called Bastion host. I think yesterday itself we talked about a Bastion host is nothing but a jump server, but the term used in AWS is Bastion host. So we can use a Bastion host to SSH into other private instances. So what we have done, I have logged into my public instance, and from here I'm able to go to my private instance, right? So I can do an SSH into my private instance. So this particular public instance is a Bastion host or a jump server. So you get into one server, from there you access rest of other servers. They are called Bastion host. Okay, the Bastion host should be in the public subnet only. Okay, it cannot be in the private subnet. Only if it is in the public subnet, you will be able to access the jump server, and from there you will be able to go into all the private machines. Bastion host security group must be tightened. So you should make sure you allow 22 only from a specified IP or specified IP ranges for your company or your team, right? Don't allow for everybody 0.0.0. If you do that, this is what will happen, right? If you do that, this is what is going to happen. Everybody is going to try to go and say accept, accept, accept. Okay, this is what they're going to do. So please be careful. So this is what we have for our VPC. We just summarized everything, right? Whatever that we talked about so far. So except one thing in that diagram, we saw everything. I'll show you which one we did not see and why we cannot see that, right? So we just have a small summary there. Whatever that we have learned, everything is here in this short form. You can just take a look at this summary. You can see here VPC peering. Today we saw connect to VPCs with non-overlapping CIDR, non-transitive endpoints. You provide a private access to this one. Flow logs you can create and set up. Bastion host. Then site-to-site VPN is what we did not see. So that is what we did not see because we need a on-prem data center or something to set up your VPN. But the concept, just understand, using just like your work from home, you can connect your home network to your VPC using your VPN connection. Except this area we demonstrated everything, and this we cannot do because we need some other on-prem things to connect, right? We need a customer gateway and all those things, but we don't have right now. So we will try to see if we can simulate something. Then I will show you later if we can simulate something and try to access it using some open VPN tools or something. Okay. Other than that, we have seen this. Now, if you would have gone back to the recording, we have done all these things. So, and we started off with this. We just started off with this, creating one VPC, and this is where we are now. Okay. So please go through this and practice. And if you have any doubts or any questions, please ask me, and I will try to clarify for you guys. Okay. Also, a request, as I requested yesterday, please go ahead and download all the materials and the videos that we have. I'm really running out of space. Sorry to say you again and again. Please download that because I could not upload any other videos after that. Already I'm 99% full. Okay. If you downloaded, thank you. And if you are not, please download along with today's videos also. I will put it there. Then you can download that, and then you can please go ahead and do it. So make sure you delete your log group. This log group will not get deleted automatically. So you need to go and delete the log group. Okay. And also please make sure you delete all the peering connections, that, this and all, right? Go ahead and remove everything, NAT gateway. And delete the endpoints, right? Everything that you need to do. So before you delete your endpoints, make sure go to your route tables and do all those cleanups, right? Whatever that you have done. Go to edit, remove this PCX, remove this internet gateway, and save this. And go back to your another route table, which has the private RT. Go to routes, edit the route, and this will automatically delete if you delete the endpoint. Go to the public RTB, go to the routes, edit the routes, and please remove this PCX, which is your peering connection. Now go back here one by one, go to the NAT gateway first, and please delete your NAT gateway without fail. After you delete your NAT gateway, please make sure you release your Elastic IP. It will get charged. Okay. Give some time, let it go. Meanwhile, we can go to the endpoint and delete this endpoint. It's all very easy to delete. It's very difficult to create them, but please make sure you clean up here so your account is tidy. Go to peering connection, select on my peering, and go ahead and delete a peering connection. Okay, delete, and go ahead and delete it. Once this is deleted, go back, select all your machines, and please terminate it. So next class we will be talking about RDS, which is your relational database services, right? So after all this, right, now your services will be small. We will be going a little bit faster. Okay. So these are all the core services: EC2, S3, VPC, IAM, right? So far that whatever we have seen. So VPC we have seen exhaustively, and EC2 we have seen completely. Okay. So whatever is needed for your both for your interview and for your exam, but you need to practice and you need to go and work on these things. Only then you will get used to. Otherwise, it's going to be very, very difficult. Okay. So wait for your instances to get terminated. Okay. Once everything is terminated, then go ahead and try to delete your VPC. Okay. All right. Any other questions, guys? Anyone has any questions? Please download it. I will upload the video today. Then I would request you to download completely. And by tomorrow, I will go and remove some of the old recordings like S3, right? I'll remove the I'll remove the EC2. I'll keep the S3 and VPC for you. So if you don't download it, I don't have the recording again. So we may need to request from somebody who has already downloaded it. So I would request you to please download those things. Okay. Make sure don't delete the default one. Just only delete the custom VPCs that you created. Just give it a time and it will get created. Okay. I will go and clean up mine. So if you are doing it, you also please go ahead and clean up. Okay. Anything else? Any questions you guys have? Anyone? Before we close it for this week. Okay. All right, guys. Thank you, and we will have a great week, and we will meet next week. Please download after I ping you the latest video. Please download the entire stuff, and then by evening or tomorrow, I will go and remove the EC2 from there. Okay. Yeah. Thanks. Thanks, everyone. Thank you. Have a great day.
Yeah. Thanks.
Bye. Bye, Rajesh. Bye.